problem 81A at the end of chapter 7 in the textbook. So we first need to classify what type of equation or reaction is happening. So we know that this one is a redox equation because you can tell that there's a transfer of electrons. Right here you just have elemental iron, and you can see over here it makes a new compound, and it's actually in the ionized form. So that transfer of electrons means it's a redox equation.
Right, and then to solve, we first need to balance the equation. And so because we have 2 irons here, we're going to need 2 irons over here. And then we have 3 sulfates over here. We have 3 sulfates over here. And so that means we're going to need another 3 over here. And then because this hydrogen gas, or this hydrogen has 3, we need to add 3 to the hydrogen gas over here. So that balances out the equation.
And that will be the molecular equation. So for the complete ionic equation, that's where we dissociate the ones that we need to. So this first one, we can't dissociate it because it's a solid, so we're just going to write it as it is. It stays in the solid form. So we have to dissociate this because we know that this is one of our strong acids, sulfuric acid, so we do have to break it up. So we have 6 H+ ions when it dissociates, and that is aqueous. And then we have 3 sulfate, which has a -2 charge. Sulfate always has a -2 charge. Ions that dissociate from that. And that is also aqueous. And then we get over here. So we know that sulfate is soluble, and this is a soluble ionic compound, so we are going to dissociate it. So we take these and switch them to get the charge. So we have 2 Fe3+ ions, which are aqueous, plus 3 sulfate ions, which are 2-. And then this is in the gas state. Oh yeah, it's aqueous, my bad. And then hydrogen is in the gas state, and we cannot dissociate gases. So write it as is, 3H2 gas. The net is the same as the complete ionic equation in this particular instance because all of these are participating in the reaction and none of them are going to be spectator ions. So you can see like elemental iron is ionizing, the state of the hydrogen is changing, it's reacting, and sulfate's combining to make a new compound. So they're all changing, so they're all active. So the net, there's no spectators to take out, so the net is the exact same as the complete ionic. This is our second problem. It's 81B. So first we classify what type of reaction it is, and it's a neutralization reaction. As you can tell that the H and the OH are going to react to form water, which is neutralizing the acid and the base, making water. So it is a neutralization reaction.
All right, so for our molecular, first of all, we can see that actually the formula is already balanced, so we don't really have to balance the equation at this point. It's already done for us, so we'll move on to complete. For the complete, we're going to dissociate perchloric acid, and then because it's a strong acid, and then for rubidium hydroxide, we're going to disassociate. You won't find this in your rules, however, the book does tell us that it's an aqueous solution, so we are going to dissociate it. And then that's going to end up forming for the rubidium perchlorate, we're going to dissociate that as well because it is aqueous. And then, doesn't chlorate dissociate too?
Yeah, so
and
for
chlorate's soluble.
This, it's going to be a soluble ionic compound, so we are dissociating it.
So yeah, chlorate is soluble, so we will dissociate that. And then we have water, which is in liquid form, so we actually will not dissociate that. So for our complete, right, ionic equation, we're going to have hydrogen, which is a plus, and that will be in its aqueous form. And then we're going to do perchlorate, and that's a minus charge. We have rubidium, which is a plus charge, and that's aqueous as well. And then we have hydroxide, which is a negative charge. And then we'll have rubidium again, which is our plus charge. And ClO4 perchlorate, and that's our negative charge. And then plus H2O doesn't dissociate, so we leave it as it is, and that stays as a liquid. And that'll be your complete ionic equation.
Then for our net ionic equation, we look to see which ones are the spectator ions. So you can see that you have your perchlorate ion right here, which stays the same on this side. It's still the same perchlorate ion, and also the rubidium ion is staying the same rubidium ion after the reaction has occurred. So those are our spectator ions, so we're not going to include them. The ones that are reacting are the hydrogen ions and the hydroxide ions to form our water. So that's what we're going to rewrite as an H plus ion, which is aqueous, reacting with a negative hydroxide ion, which is aqueous, to form